Hey, this is Mr. J. Let's go through 3 examples of solving for missing sides in similar triangles. All right, first example, we've got 2 right triangles here. It looks like we've got a small right triangle and a big right triangle. Looks like we're missing this side here from the small right triangle. So if we're going to go from 20 down to x, that looks like we're going to have to shrink 20 inches, okay? So let's do a small over big proportion because we know we got to set up a proportion. And in this case, to go from 20 to x is going to be a shrink, and so we know that this is going to create a scale factor that's less than 1. All right, so here we go, small. So we got to do the small side here, x over 20 there. So if I started out with x here, then I've got to do is equal to 10 over 25 in the next one. So again, you've got the small sides in the top, and you got the big sides in the bottom. You've got the x over 20 is equal to 10 over 25. So now let's cross multiply. So you've got 25 times x is 25x. You've got 10 times 20 is 200. Divide by 25, and it looks like x is equal to 8. All right, that should be a good answer, but let's just plug it back into our proportion and check. All right, so we're pretty sure that 8 inches is the answer here, but let's check this proportion 8 over 20 and see if it reduces to 10 over 25, the same fraction. All right, so there's a 4 in here, so that reduces to 2/5. There's a 5 inside of the 10 and 25, so that reduces to 2/5. And so for sure, our length of 8 inches is the correct length for that missing side in the small triangle. All right, moving on, number 2. All right, so in number 2, we know that we've got, let me go ahead and mark this up, missed that a little bit. We know that we've got angle similarity. Why? So starting out here, we've got this segment drawn on the inside here that's parallel to this third side. It creates a small triangle, and we got a big triangle. We know that that automatically creates similarity. We know that these angles right here are corresponding angles because you've got this transversal cut by 2 parallel lines. You've got these 2 corresponding angles. And again, the third angle here is a shared reflexive angle like we've talked about. All right, so we know that there's similarities. So let's move along and find the length, find the missing value of x, so we can solve for all the missing sides. All right, so looks like we've got to figure out what this length is here. Well, that's going to be easy to do. If the entire length here of the big triangle is 7 and a portion of that is 4, 4 from 7 is 3 centimeters. So we've got that right there. So we're good to go there. And now then we're ready to set up our proportion. The way that I like to set this up is just think of this as a fraction. So let's come over here and create the 6 over x plus 2 is equal to, well, if I did 6, I got to do 3 in the top here, like that right there, and x plus 2 is going to correspond and go with 4. All right, so this is a little bit harder. Let's work this out. All right, so let's do 4 times 6 first, which is 24. 3 times x is 3x, and then plus 3 times 2 is 6. All right, a couple of steps to solve. Subtract the 6 by doing opposite and getting across the equal sign. We got 18 is equal to, bring the 3x down there, divide both sides by 3, and we get x is equal to 6. All right, so let's check that there as well. So let's plug this in here. So we know that it should be about 8 centimeters when we plug in there to find the length, right? So we've got 6 over 8, right? Plugging in there as well. Is that equal to 3/4? All right, quick check. There's a 2 in there, so that divides to 3. 2 in there goes to 4. So sure enough, we've got our 3/4 is equal to 3/4. And so we know that 3/4 is the scale factor. All right, and we solve for the correct missing length there, which was 6. All right, so everything's solved for. Here we go. Let's move on to the last example. Last example, we've got a big right triangle and big right triangle. Same thing, my bad here. Let's set that parallel to that right there. So we've got this segment here that's drawn in the middle inside of the big triangle, and it creates automatic similarity. So these 2 angles are going to be corresponding angles, so we know that they're going to be right angles as well. So we've got our angle similarity. We're ready to move on. All right, so what do we got here? Same thing. All right, so the whole length is 9. Subtract 6 from it. So that leg right there of the right small triangle looks like it's 3 feet. And now then we're ready to go. So it looks like here we're going to stretch 4 to a longer side x. So let's do us a big over small proportion in this case. All right, so let's start out with x, which is the big vertical side. Let's put that over 4, which is the small vertical side. Now then we got to come over and get the big triangle's full length, which is 9. And then let's put that over 3. Make sure you don't inadvertently grab 6, right, and everything. That's just a portion of the big triangle, and it's not part of the small triangle. All right, so here we go. 3 times x is 3x is equal to 4 times 9 is 36. Divide both sides by 3. So x is equal to 12. All right, so let's check that right there. And sure enough, 4 goes into 12 3 times, just like 3 goes into 9 3 times as well. A quicker way to work this out was to realize that you already had this scale factor there. So let's do the 9 over 3, and let's just multiply by the side that we're trying to make larger or stretch to get to the x. And so we do that right there, like that right there with a 4 over 1. And so you get 36 over 3 is equal to 12 feet. All right, so you could have done that up here in this number 1 as well, right? You already had the scale factor here, and so you could have multiplied 10/25, or what would that have been, 2/5 times the 20 and everything, and it would have shrunk that down as well. All right, so there's 3 good examples of similar triangles where we're missing sides that have been worked out, and we can now solve for all the missing sides in the triangle. If we wanted to, with the right triangles, we could do the Pythagorean theorem to find those lengths of those hypotenuses. Thanks.